So what we're looking at here is airtightness. And the question that was posed to us, I think in the marketing for this, was, are we sealing our homes too much? And hopefully from what you've already heard today, you can quite clearly see that we're not. We're nowhere near sealing our homes. And I think it's also common in New Zealand to assume that excess ventilation and infiltration is a good thing, but it is not. Airtightness is vital to create this warm and healthy internal environment, and moisture management and airtightness go hand in hand. So intelligent moisture management reduces moisture entering cavities, condensing and forming mould. And this will happen in the Auckland summer, where it's potentially more warm and humid outside than it would be inside the building, and in the Queenstown winter, where it's a lot warmer inside and colder outside, but you get different transfer of moisture within that cavity. But basically, condensation will enter on the warm side, and if it cannot escape on the cold side, then it will condense. And this is what we're looking at here. We've got an internal temperature of 20 degrees C and 50% relative humidity. And you're looking at a 1 millimetre gap. So what we're talking about there is just somebody taking a scalpel to a piece of plasterboard, creating a very small gap, and you're getting 36 grams of moisture per day condensing either on the back of the cladding or the roof cladding. So that is the same as a can of Coke condensing on the back of this cladding. So you can see the extent of the problem. So you imagine roof lights, downlights, or a T&G ceiling, just how much moisture is travelling through into our cavity. So some details. So this is looking at common New Zealand ways of building, and yesterday the Zero House, this is similar to what they were using, but I don't think they were using airtightness, but they were using this double framing. And we also looked yesterday at the problems where, and the guy this morning, with the what do you do with all your electrical cables and plumbing and so on. So this is a detail that we commonly use, and this zone here is the service cavity, and it means that this dotted blue line, which is the air tightness layer, is continuous on the same plane throughout the building. And if you keep it simple like this, it's easy to construct. And it also means that you don't have the problem with the services, and you don't have the electrician or the plumber coming on site cutting through your air tightness layer, which you've just spent some money on, and giving you a problem. So it keeps things really simple. But the devil is in the detail, as with everything, and it's just, if you can't draw it, if you've got lots of difficult and complicated junctions, then you're not going to be able to do it on site. So that's why you need to keep things simple. But what we found is that with this detail as well, it also highlights the need that the contractor needs to be fully aware of what standard of air tightness you're trying to achieve. In Queenstown, we've got builders which are now competing against each other to try and achieve a better air tightness than the previous set of builders or their previous sort of opposing team. So that's ensuring that we've got a constant improvement. And it also means that the foreman is the last person on site taking extra care that one of the subbies might have cut through that air tightness layer. So this is another detail, just when we talked previously about the gaps around the window, and this just shows where you need to tape fully and bring the linings completely into the recess. And it also shows if you do have situations where you have to take pipes or electrical cables through the air tightness, so this is using ply as an air tightness, and this is using a vapor jet, you need to fully tape around them or use specially designed grommets to make this work for you. You also need to think about unseen areas, such as behind kitchen cabinets and raised sort of floors or drop soffits, and also things like your intermediate floor details, or where you've got internal walls butting up against the external wall. All these areas need to be completely airtight. So I was going to ask everyone, but I think we've already covered this, but hopefully everyone can remember what the average air change rate at 50 pascals is for a new house in New Zealand. Anyone remember? Not you. 5, that's right. So can anyone guess what an old house might be? Not you.
15, 20?
Okay, it's 20. That's what we've been finding, and in some cases you might not even be able to reach that pressure of 50 pascals, so you can't even get a reading. So that's how bad our existing stock is. So obviously we've brought along this blower door here today, and if anyone wants to ask any questions about it, then Denise at the back there is our blower door tester, and we'll be here till around 2, but then Denise and Paula are going to measure the Geyser building, which is the latest Green Star building in Auckland, and then we're going to be doing the first passive house as well with this blower door test. So just to give you a bit of an example of, well, I'll just talk you through these figures to start with. So passive house criteria at this 50 pascals is 0.6 air changes per hour. And the European standard when you're employing mechanical ventilation is 1.5 air changes per hour. So as I just said, we've got new houses that, and also I should point out that in New Zealand there is no standard. So this is just an average of what we're sort of finding when we're looking at houses, and that's new is around 5 and old is around 20. My own house, which is a typical Queenstown 1980s partially insulated house, was tested the other day, and I achieved 10.83 air changes per hour, so I was quite pleased that I was on the scale. But still, it also highlighted where there's common places where, because I'm assuming not everyone's going to be in a fancy new house, and we had quite clear areas where the seals had pulled back on my windows, where the wind was basically whistling out. And I've been obviously known about this, but I hadn't realised just how bad the problem was. So that's a relatively easy thing for me to change, and I've got crappy single glazing aluminium, which means that I've got this fantastic view of the lakes and mountains, which at the moment I can't see because I'm looking through condensation. So, you know, that's what we're dealing with. We've got these wonderful houses in great locations, but what's the point if you can't see the view and you're bloody freezing the majority of the time, or you're in Queenstown at this time of year. So, and you can see why it's so hard with that 10 air changes per hour. So that's the entire volume of air in my house that at that pressure is being exchanged. So you can see why it's so hard to reach the World Health Organization standard of 18 degrees within your house. Like, I'm nowhere near 18 degrees at this time of year, even in the summer. So with passive house and with this form of construction with airtightness, we're not sealing our house. You're still able to open any doors or any windows anytime you like, and with the good balanced heat recovery system, you're also getting as much fresh air as you need all the time. So you're getting much more fresh air than if you're just using infiltration. Mine's gone pink too. But what we're looking at here is a ventilation system such as the ones we're talking about, which is a balanced system. So we've got supply air going into the bedrooms and extract from the kitchens and bathrooms. So in addition to this, with passive house or any thermally efficient and airtight building, actually I'll just go back and tell you, I forgot to say, the definition of a passive house is a building for which the thermal comfort can be achieved solely by heating or cooling of the fresh air volume required to provide good indoor air quality anyway. So in other words, your ventilation system is the only thing you need to provide the heating for your house or the cooling for your house in somewhere like Auckland. And these systems are not expensive. We've just had one price for a house in Queenstown that was $8,000. And this was using the European ducting, which is like the high quality ducting. If you exchange that for New Zealand ducting, this would be at least a couple of grand cheaper. So if you compare that to a diesel or a ground source heat pump, you're looking at 10 times that much, and you're getting an efficient system that is low cost to run. And it's providing warm air everywhere in your house, and it's providing fresh air everywhere in your house. So for passive house, these systems are required to be 75% efficient as a minimum, although some of them are 95% efficient. And that means that all the hot air that's leaving the house that heat is being transferred to the supplier that's coming in, so you're retaining 75% of that heat. And it's coming in at a very low velocity. It's 0.2 meters per second, which means that you're not like what we're used to with these heat pumps blasting down on us and being really uncomfortable. It's a very comfortable form of heating. And it can be increased or decreased depending on what you're doing. So if you're having a shower or cooking a smelly curry, you can just put it on and take more air out. Or if you're leaving your house and going on holiday, you can just put it on a very low setting, which means that you don't have to leave windows open and have potential security risks. So final slide, in conclusion, New Zealand is a very different climate across the length of this very long country, and I'm still getting used to the fact when I come up to Auckland that I've got to take about 10 different bits of clothing with me because the weather is different as soon as I leave the building. It's going to change throughout the day. And for people who don't live in Queenstown, you won't appreciate just how bloody cold it is at this time of year and how dry and hot the Central Otago climate is in the summer. So our New Zealand building code does not account anywhere near for this range in climate. And as we already know, we're not even reaching this. So if you look to passive house, or at least the principles behind it, you're designing specific for a climate. So we need to raise the standards of our design and detailing if we're to utilise ventilation effectively. Ventilated buildings can bring in the required amount of fresh air per person for them to be able to operate effectively both at home and at work. And it can also be a very effective and comfortable way to heat or cool your building to the required temperature. But this must be done in conjunction with airtightness and thermally efficient design. That's it.